In ancient times, humans watched the skies looking for clues to their future and to aid in their very survival. They soon observed that some stars were not fixed, but moved in the sky from night to night. They called these stars the Wanderers. At the center of our solar system is the Sun, binding the planets with its gravitational pull. From our viewpoint on Earth, the Sun appears small in the sky, but in reality, it dwarfs even Jupiter, the largest planet in the solar system. The distance from the Sun to the small worlds traveling around it are vast. Light from the Sun takes 8 minutes to reach Earth, and nearly a day to reach the farthest known bodies. Join us now as we tour our solar system, starting with sun-baked Mercury and traveling to the remotest outskirts, where small, icy bodies move with only the faintest connection to our Sun. Mercury, the closest planet to the Sun, is also the smallest terrestrial planet. It orbits so swiftly that its year lasts only 88 Earth days. The airless cratered surface could almost be mistaken for our moon, relentlessly bombarded by meteoroids for 4.5 billion years. One of these encounters left a giant scar known as the Caloris Basin, one of the largest impact sites in the solar system. Temperatures on the surface of Mercury can reach a blistering 800 degrees Fahrenheit, but can dip to 300 degrees below zero on the night side. Seen from Earth, Venus is the brightest small object in the sky, thanks in part to an unbroken layer of sulfuric acid clouds, part of the planet's thick, smothering atmosphere of carbon dioxide, a potent greenhouse gas which traps the Sun's heat and turns the surface into a desert with temperatures of 870 degrees. Venus rotates so slowly that a day lasts almost as long as 4 months on Earth. Devoid of water, the surface is a nearly uninterrupted expanse of rolling volcanic plains. As this altimetry image shows, a few highland plateaus in red and broad depressions in blue dominate the landscape. In the 1970s and 80s, Soviet landers survived on the rock-strewn surface of Venus, just long enough to give us our first glimpses of the planet close up. The Earth is the one body in the solar system where water can exist stably as a gas, liquid, and solid. And this has made all the difference. Vast oceans dominate the planet. Clouds cover much of the surface. And the polar caps and sea ice grow and shrink with the seasons. The Earth's solid surface is itself dynamic, shifting and recycling through the process of plate tectonics. Together, these complex and vibrant systems make Earth the only known haven of life in our solar system. Evidence of the teeming bustle of life here, thriving on our small, watery oasis in the vast, unfriendly desert of the cosmos, is even visible from space. Mars was once a geologically active planet with the largest volcano in the solar system, Olympus Mons, and Valles Marineris, a valley that dwarfs the Grand Canyon. It has the most Earth-like environment of any other planet, but with its tenuous atmosphere, frigid temperatures, and radiation-drenched surface, it still cannot support Earth-like life. Thin as it is, the Martian atmosphere is incredibly dynamic. with seasons and polar caps that grow and shrink. Often large dust storms begin to swirl in the deeper basins. Sometimes these grow into massive globe-encircling maelstroms that can cloak the entire planet for weeks at a time. This map of Mars reveals one of the most puzzling features of the planet: the contrast between the smooth, low-lying northern hemisphere in blue and the craggy, heavily cratered southern uplands in red. Why are the two halves so different? Did water ever pool in the low-lying areas? And was there ever life here? The planet is now a vast, barren desert, but images of what look like dry river channels and ancient lake beds provide compelling evidence that liquid water once ran over the Martian land, at least for a time. Mars has had more visitors in the form of landers and rovers than any other planet, but many puzzles still remain. Beyond Mars is a vast region of space known as the main asteroid belt, a graveyard of millions of rocky pieces of shattered young planets and bodies that never got a chance to grow. Asteroids come in all shapes and sizes, but most of the material that was originally in this region is long gone. So what happened here? Why didn't these asteroids ever come together to form a planet? What was responsible for throwing most of the material out of the asteroid belt and causing all of these massive collisions? Something big. Something really big, and it's our next stop. Jupiter is the largest planet in the solar system, a massive giant that twirls around so fast it completes a full rotation in a mere 10 hours. The movement of the clouds reveal nearly constant high-speed winds, and the cloud tops are marked by fierce storms larger than Earth, some of which can last for centuries. Jupiter is surrounded by faint rings and more than 63 moons. The largest moons are worlds in their own right, and were seen in even the earliest telescopes. Io, forever pulled and tugged by Jupiter, is volcanically active, spewing sulfur compounds onto its exotic surface. Icy Europa has a cracked surface that very likely hides an ocean somewhere below. Ganymede, with its surface of dark ice and bright craters, is the largest moon in the solar system. And heavily cratered Callisto is marked by the impact of many tiny objects, each one trapped and pulled by Jupiter's overwhelming gravity. Next, we move to beautiful Saturn. Saturn's atmosphere at first appears to be serene, but this planet, too, hides powerful storms and winds. But Saturn's most obvious, most majestic feature is the extensive system of rings, a graceful collection of ice, rocks, and dust shepherded into place by small moons. Images of the rings reveal lovely scallops and swirls caused by the moonlets embedded within. Saturn is also surrounded by more than 60 diverse moons, including cloudy Titan, which has an atmosphere of thick hydrocarbon smog covering an icy surface dotted with methane lakes, sand dunes, and icy volcanoes. Another example is odd Iapetus, with its stark contrast of extremely dark and very white surface features. And don't forget tiny Enceladus, residing deep in Saturn's gravitational thrall. Pushed and pulled by strong tides that help activate geysers, Enceladus alone provides enough water ice to form one of Saturn's tenuous outer rings. This is Uranus, the first of the ice giants. Uranus receives 400 times less sunlight than Earth, and its clouds lie deep in the atmosphere, masking the planet's turbulence and giving it a calm blue color. But Uranus is special. The planet lies nearly on its side, and this extreme tilt gives rise to seasons that last nearly 28 of Earth's years. As previously dark areas of the planet receive sunlight and begin to warm, powerful storms build in the atmosphere. Like the other giant planets, Uranus has many moons and faint rings, few of which have been seen close up, and it's only been visited by one spacecraft, Voyager 2, in 1986. The final giant planet is Neptune, the other blue planet. It is also a stormy planet, though it is even colder than Uranus, and the seasons are not as extreme. Like all the giant planets, Neptune has faint rings, and it radiates more heat than it receives from the Sun, a likely cause for its extremely high-speed winds. Though only briefly glimpsed in 1989 by Voyager 2, Neptune harbors fascinating moons. Triton, likely captured by Neptune when passing too near, has a surface marked with nitrogen geysers that form a thin atmosphere. Who knows what other surprises await on the moons of Neptune? Beyond the main planets lies a region with many dark and icy objects, called the Kuiper Belt. Some of these bodies cross Neptune's orbit, and this region is home to comets, rocky bodies, and dwarf planets like Eris, Haumea, Makemake, and Pluto. Pluto, once classified as a planet, may have a thin atmosphere that freezes to the surface during winter and has at least 4 moons, including Charon, Nix, and Hydra. Far beyond the Kuiper Belt is the Oort cloud, a vast region that encloses the entire solar system. This is the realm of many long-period comets, bound by the Sun's gravity, with orbits of a couple hundred to thousands of years. Packed as it is with all these marvels, our solar system is not unique. Throughout the Milky Way galaxy, many stars have been found with planetary systems of their own, filled with exotic new planets. Planets bigger than Jupiter, and yet closer to their stars than Mercury is to our Sun. Other planets quite similar to Earth. Imagine the night sky from some of these planets. Planetary wanderers abound in our galaxy. As we find ways to study even further stars, what other solar systems await discovery? Perhaps emerging civilizations on those planets look out into their own night sky as well and ponder the nature of their own wanderers.